Hello everyone and welcome to this episode of the Intro to C++ series, where today we're going to be talking about math. Fun topic math is. And basically what we're doing is we're going ahead and expanding on what we had last time. So if you remember last time, what we did was we talked about these three fundamental data types that we have. Our int, which holds all of our integer values, or whole number values, floating point, or float, which covers all of our numbers that require decimal points, and our Boolean values, which handle true and false logic. Now today, since we're going to be talking about math, we're not going to be talking about bool too much, so we can go ahead and get rid of that guy. And for the sake of simplicity, I'm not going to be talking about floats either. All of the math that we're going to do is going to be integer math, but everything that we're doing in floating point math, in integer math, also applies to floating point math. There's going to be a few little, things at the end, but we'll talk about that later on in the video. So let's just say that we've got some variable. We're going to call it var1. And we're going to set it equal to 24 plus 5 times 2 and let's go ahead and start off with that. var1 equals 24 plus 5 times 2. The really good thing about the way that math works in C++ and most, if not all, programming languages is that math works in programming just like it does in real life. In real life, you would not solve this problem going left to right. You would not say 24 plus 5 divided by 2. That would be incorrect. The way that you would do it is you would follow the order of operations, the stuff that we learned back in elementary or middle school, whenever that was. So what we would do is we would do 5 times 2, and then we would add 24 to get a value of 34. A real quick way to go ahead and verify that our value is correct is by running our code, but we don't get anything. What we get is just this window down here, and it doesn't help us out very much. But what we can do to help that is we can use what is called the debugger. And the debugger is going to help us tremendously when trying to figure out what's wrong with our code. We can look at all different kinds of variables. We can take basically what's called, or what I'm going to call, a snapshot. So we can basically take a photo and see what's going on with all of the variables in our program. And in order to do that, what we need to do is we need to think about it. We need to see what's happening on line 3. So line 3 has to have run, and then we can take a look at it to see what happens. In order to do that, we're going to go look at line 4. So we're interested in line 3, so we're going to go to the next one down. And in this gray sideline over here to the left, we've got, you can see that the mouse cursor changes. And if I click on the gray area right next to the line 4, you'll see this red circle appear. And what that is it's called a breakpoint. And basically, whenever the code reaches the breakpoint, the entire program will stop running. So what's going to happen is when we run our code, it's going to say int main, okay, open bracket, okay, int var1 equals some math function right here, boom, and then it's going to hit this breakpoint and say, all right, okay, I'm stopped. So let's take a look and see how it works. So we have our local Windows debugger, like always. We go ahead and click on it, and we have a new box that opens up. And in this box, we can type in, you see we have autos, locals, and watch 1. I'm going to be using watch 1 just because I want to focus primarily on the variables that I want to focus on. So we want to take a look at var1 and see what value it has. So as you can see, we have this area called name, and this area called value, and this area called type. So basically what we do is we type in the name of the variable that we're interested in, and it'll return to us its value and its type. So if I say var1, and it is case sensitive, var1, it says 0x00000022, and it's an int. Okay, that's weird. That's not what we expected at all. If you didn't get this and you got the proper value, then good for you. Your development environment is set up properly, I guess. But if this is what you get, what you can do is you can type in, or you can right-click this and click on hexadecimal display, make sure that this arrow is ticked off so that we can get the value of 34. What it was doing is it's converting our number from a base 10 system to a base 16 system, but that's not important right now. Yeah, so if I go ahead and click on the hexadecimal display, make sure that that box is not ticked, we see that we get the value of 34, which, like we predicted, is the result of 5 times 2 plus 24. Go ahead and hit continue, and the code will will finish running. What we can do, just like in regular math though, is we can add parentheses around certain numbers so that those get calculated first. So you can see 24 plus 5 and then times 2. That's 29 times 2. It should be what? 58, right? We'll see. We'll go ahead and click on the local Windows debugger, and just like last time, we have our breakpoint here, and I'm going to build it. And var1 equals 58 is basically what we can see here, and it's a type int. And basically, well, I just took that breakpoint off, and we can keep going with this. We can say 2 divided by 1 plus 18 minus 32. Doesn't matter, right? And if we put parentheses around some of this stuff, then it'll be run first. And, oh, I took off that breakpoint. Let me put it back. And we get the value of 44 because it'll do this one, and then it'll do these, and then it'll do these. Really simple stuff. But you want to do is you want to make sure that if you are creating a situation where you're going to be ending up with floating point values, so for example, float var2 is equal to 1 divided by 6, this might not actually work as well as you'd like it to. So if I add a breakpoint, and I put another watch on, and I'll watch var2, we can see that for some reason this is equal to 0, when we should expect it to be equal to, what is it, 0.166. And that's because we need at least one of these values to be a floating point value, because what it's doing is it's taking a look at an integer divided by an integer, and it's going to round down to the nearest one. So if we had 7 divided by 6, what it'll do is it'll give us the number 1, which is not correct. So what we need is 7.0 divided by 6, and so then we get 1.166, which is exactly what we'd expect. What I like to do is I like to make both of these values floating point. I don't like it when I see them being mixed and matched. There are ways around that, but we'll talk about that later. And that concludes that anyway. Now let's get into something a little bit more concrete. We were just talking about something abstract. Now let's talk about something that actually relates back to games. And if you've ever played an RPG before, like Persona or Final Fantasy or something like that, then you'll know that all of the values that you need for battle, so your health and your ability points, and maybe you have some other stuff going on, all of that info is on the screen readily available for you. And in the case of Persona, two of the main properties that we need to watch out for with our character is we have our int health points, and we have our int, I'm just going to call them ability points. They're called SP. I don't really know what that stands for, but we've got our health points and our ability points. Let's say we've got 100 health points and we've got 50 ability points. Okay? And let's say that we get hit. Our character gets hit, and we need to actually make sure that our health points go down. So what I can do is I can say health points, and it's going to be equal to, I'm going to have to copy health points, because I can't just say, we get hit and get dealt 8 damage. I can't just say health points equals 92, because then what if we get hit again? Am I then going to write explicitly health points equals 92 minus 8? Like, maybe that value is different every time. So what we'll do is we'll copy the value of health points and subtract 8 from that. So then what we have is a situation where we say health points is equal to 100 minus 8. And then what we can do is then we can do that again. So if I copy and paste this, it'll then go health points is equal to 92 minus 8. So I'm going to add another breakpoint so we can go ahead and watch our variable a little bit more closely. So I hit local Windows debugger and start that up. var1 and var2 are undefined, I know. So I'm going to go ahead and right click and delete. And we're going to watch health points. So our health points initially was at 100. Then we had health points equals health points minus 8. So it brought it down to 92. Then what we can do is we can actually move this breakpoint down by one line at a time by using the step over by clicking this or pressing F10. When you do that, you can see that we move basically down one. You can see that little yellow arrow on the side. And now our health points is at 84. Because what we did was we said health points equals 100, then subtract 8 from that, then subtract 8 from that again. And that's basically how that's going to work for us. I'm going to hit continue, and then it'll run the rest of the code. And that's basically how a majority of game code is written. So if you've got ability points and you use an ability equals ability points minus 24, for example, it'll subtract 24 ability points from your character. Now, there's actually a really nice shorthand way of writing this, and it's actually health points minus equals 8. And basically, this just means the same thing as that. Health points minus equals 8 is the same thing as health points is equal to health points minus 8. You'll see this a lot more often than this just because it's way shorter, way easier to write. Fewer keystrokes make a happier programmer. All right, and that's pretty much going to be it. Remember that this works the same way as float. So if I say float health points and float ability points, this is going to work the same exact way. So when I hit the debugger, I can see that it's equal to 92.0000. Remember, this is a floating point, so it does have decimal places after the fact. And when I decrease it by 8 again, it's equal to 84. Oh, that was ugly. When you get to the end, just go ahead and hit continue. Don't try to step over because then things break. And yeah, that's going to be just about it. Remember that we don't like to add and do math with mixing together floats and ints though. So this might not be what you want to do. You might want to say 8.0 minus 8.0 just to make things a little more explicit and clear to you. and that also helps to avoid bugs. That's going to be it for that, but we also have a challenge. Now, for most videos, we're going to have some sort of a programming challenge, and it's going to be associated with the video that we watch. There's going to be some things that are cumulative, so we're going to talk about math and other tutorials. We're not just going to say, oh, right, yeah, we're done talking about math because that's over. These are going to be cumulative, so let's take a look at the challenge, shall we? This right here is a formula that if you've ever taken a physics class, you are very familiar with. What this formula is we're going to use it to model a ball dropping from a particular height. So this is our position. So position final is equal to position initial plus our velocity initial times time, and then we're going to multiply that by half g times time squared. G is the acceleration due to gravity. So what we're going to do is basically what this formula says is if I drop a ball from the top of a building, right, it's going down, I drop it with an initial velocity of 0. So I'm not throwing it down, I'm just straight up dropping it. If I drop it from a height of 100 meters, G is a constant. That's always going to be 9.8 meters per second squared in this context anyway. And after 3.4 seconds, how high up is the ball still from the ground? So in order to solve this problem, we're going to use our knowledge of C++. So you might say something along the lines of position final is equal to, and go ahead and plug this equation in and see what you get. Use breakpoints and use parentheses however you need in order to be able to solve this problem. Ready and go. All right, I'm back. How'd you do? I'm going to go ahead and share my my personal solution to this problem. This might not be the only solution. If you didn't come up with this exactly, then there's nothing necessarily wrong. But here it is. So we need to know that 3.4 seconds have passed. So I'm going to store that into a variable 3.4, and I'm going to call it time. Same thing with our float. Acceleration of gravity is equal to 9.8 meters per second squared. And our initial position is 100 meters off the ground. Now, what I have done is I have prematurely omitted the multiplication of the middle term from the calculation. So what I did is I said, hey, why am I going to waste precious time multiplying 0 times 3.4? I already know that that's going to be 0 because, you know, anything multiplied by 0 is going to be 0. So what I did was I basically just plugged in this entire equation with the exception of that term. So I've got position final is equal to position initial, which should be a decimal value, position initial plus, and then I have this all in parentheses just to make it nice and clear, 0.5 times the acceleration of gravity, g, times time, which is, you know, anything multiplied by itself is going to be squared. So I've set up a breakpoint just so that I can look at the value that we have. So go ahead and build that. And the value that I get is 43.3559952. If you got a value somewhere in that ballpark, so 35.355, area, then congratulations, you did it. If not, then go back and look at your code and see what you could have done incorrectly. Maybe you had some of these values as integers. So if I have int, and int, and might as well make this an int just to prove the point. If I make all of these integers, then I'm going to get some wacky value of 59. Now, I don't know how they actually got the value of 59 because I believe this should actually truncate down to 0, but I'm not 100% sure because it's not a variable. But it's very interesting. But yep, go ahead and make sure that you've got the value of 43.355. And if you didn't and you still don't know what happened, go ahead and leave me a comment in the comment section down below asking why. If you're new to the channel, go ahead and hit the subscribe button so that you can get more of these tutorials every Friday. And that'll be it for me. So I will see you on the next one.